Good evening and welcome to the University of Denver's virtual open house, our engineering session. Thank you for joining us this evening. My name is Shayna Pomager. I'm the Director of Visit Programs, and we're excited to be able to dive deeper into the world of engineering. Before we get started, there is an option for closed captioning for this program, and we will be using the Q&A feature to be able to get your questions answered. And I'm going to go ahead and turn it over to my friend and colleague, Dr. Rizal, so she can tell us more about the engineering program at DU.
Yes, thank you so much. I'm so happy to be here and to be able to speak to you all and hopefully answer some questions that you have. So at any point, please go ahead and type questions into the Q&A. While I'm presenting, I'm going to probably present for about 15 minutes, 10, 15 minutes about our program. And then really, I want to dive into your questions because that is, I find, the most helpful part. So if I'm presenting and I see a question, I'll answer it, but know that even if I don't get to it during my presentation, I'll make sure that we answer all of those after I am done with that portion. So I'm going to share my screen and we will get started. Hopefully. There we go. All right. Hopefully everybody can see that. So welcome to my presentation about the Daniel Felix Ritchie School of Engineering and Computer Science. And specifically, I am going to be talking about the engineering part of that. So as mentioned, I am Dr. Brie Roselle. I am a teaching professor and the chair of the Mechanical and Materials Engineering Department here at the University of Denver. There's a few other folks I just wanted to mention who could be helpful on your journey of, figuring out if DU is a fit for you, which of course we hope it is. And so they're also available for other questions that might arise. And so that is Dr. Gonzalo Martins, who is our interim chair of the Electrical and Computer Engineering Department. So he is my counterpart in engineering. And then also Dr. Jason Roney, who is our newly minted Associate Dean of Undergraduate Studies. And he also teaches in the Mechanical and Materials Engineering Department. We're all here to answer your questions. I will make sure that at the end, I have a slide with email addresses and places where you can locate us. So if questions come up after this presentation, we are more than happy to answer those for you. So let's get started. So who we are, right? What is the School of Engineering and Computer Science at DU? So we, as I mentioned, have two engineering departments, Mechanical and Materials Engineering and Electrical and Computer. And a little bit here, I'll dive into a little bit more information on, what programs we offer, what that looks like. And then we are also housed in the same building as our Computer Science Department. And we really like this because those are three departments that truly are interdisciplinary and work together. And so as an engineer, you'll take some computer science classes and perhaps vice versa. And so being able to be housed in one building, working together and integrating as colleagues is really important to us. All right, so just a little bit about this school. These are some of our undergraduate student enrollment numbers over the past few years. And you can see by that grand total at the bottom that we have been increasing. And actually, I'm going to pull the fall 2024 numbers very soon, and they are also increasing. So I had one of my largest first year engineering classes this past year. And large is relative, of course. So I'll talk a little bit about that. But you can see that we have several different majors in the school. So in the computer science side, we have animation and game development, applied computing. You can see those numbers. And then in engineering, as I mentioned, we have mechanical engineering, electrical engineering, and computer engineering. And then along that, we have minors in most of those majors. And then we also have a minor in biomedical engineering, which wouldn't be showed in these majors, but is also a piece of our curriculum. Our most popular majors in the school are going to be our bachelor's of science in computer engineering and then mechanical engineering. But overall, we have a really good kind of spread between our students. And as I said, we all often work together in the same courses and collaborate together as well. So I have those numbers. They can look kind of big, but I do want to point out that even though for us, we're getting larger numbers, we're still maintaining our smaller class sizes, which to me as an instructor is one of the biggest differentiators compared to I went to big state schools that I loved, but I sat in a classroom with 400 students. And even in my major classes, there was between, 100 and 150 of us in a classroom. What this chart tells us, which I really like, is it gives you kind of the percentage of our classes that have different class size ranges. And so you can see our biggest classes are these really, really small ones down at the bottom. And so any class that's going to be over 40 students, that's really making up a fairly small percentage, like less than a quarter of the courses that are taught in our school. There might be classes like your introductions to chemistry, your physics classes. They may be a little bit bigger than that, but they're never going to be, more than 100 students in a lecture. They're always going to be on the smaller side. And that I think is really important, especially once our students get to more specialized courses. So in their junior and senior year, especially when we get to things like our engineering electives, these are classes where you may only have, 10 to 20 students in a class with you. And we get really great experiences between faculty and students and what that interaction looks like. Additionally, even though some of our classes might have slightly larger lecture sections, so for example, my Introduction to Engineering Design course, I might have closer to 50 students in a lecture, but then the lab has somewhere between 18 and 20 students. So you get a lot more interaction with our graduate teaching assistants or with myself as the instructor in a smaller environment as well. So I really think that's something I like to point out. My goal with this presentation is to really describe how is engineering DU unique, right? Why is this going to be different than going to other engineering programs? And so class size is a place I start because that really is a differentiator for us. The other thing, or the next thing I'm going to mention is our undergraduate engineering curriculum. And so our curriculum is unique, and I'm going to show a little diagram here that'll show you what that looks like. In that, for the first 5 quarters, so DU is on a quarter system. There's 3 quarters in the traditional academic year, so fall, winter, spring, and then summer is an option as well for students to take courses. But for the first 5 quarters, so basically all but the last quarter of your second year, we have a common curriculum for our engineering students. So all of our first year students are going to come in together as a cohort. They're going to take courses like my Introduction to Engineering Design course together, their calculus, their physics, their chemistry. They're going to move into things like Intro to Programming. And in the second year, starting to look at courses like their statics courses, circuits. You're going to get the base kind of level of all of our majors so that students have 5 quarters to get to know each other, right? Really learn the school, build a community, but then also decide which of the major options is going to be the best for me. And so, again, all of our majors are listed here. And then the one that wasn't shown earlier as well is we do have a concentration in mechatronic systems that aligns with our electrical engineering degree. And so up and through until the 5th quarter, our students they're all working together and they still have an option to switch to any of these engineering programs. And so if you come in as a mechanical engineering major, but then really decide, oh my gosh, I loved my circuits class, I think I want to learn more about electrical engineering, you have that opportunity. And so it's that last quarter of our students' second year where they start to split off into these different majors with your more differentiated curriculum. And so during that time, once our students have split off, that's when they really get to dive deep into these different majors. So, in electrical engineering, you're going to take more circuits classes, electronics, you're going to learn about microprocessors and all of those kind of things. And then, in mechanical engineering, you're going to take your thermodynamics and fluid mechanics, which are my favorites, but also go more in depth in the mechanics side of things and take a material science class. And so you really gain your expertise in your field, which works out really well because at our school, one thing that is unique is our design courses are also interdisciplinary. If you're looking at engineering schools, you've most likely heard of either, they might call it senior design, capstone design, engineering design, but it's some form of your last year of study, you're going to be working on design projects. And here at DU, we take our students who have, kind of spread out, learned their different specialties, their different majors, and then they're going to come back together and they're working on those projects in interdisciplinary teams. Why is this important? It turns out most engineering problems are not solved by a single type of engineer. So if I am trying to solve a problem even about an airplane or a car or looking at a medical device, I'm probably not going to only need mechanical engineers. I'm probably going to need a combination of different, types of knowledge and skills that we can bring together. And so what's really great, and these are pictures in this slide here of our senior design projects being shown off. is that we bring our students back together. That also is another reason I really love that common curriculum kind of cohort feeling we get in those first 5 quarters, because even though you might be a mechanical engineering major and an electrical engineering major, you probably met each other during that common curriculum. And so our students really get to know each other, even if they aren't in the same degree, so that when they come back together, they're already ready to form a team to start working together, which is really something that we appreciate. So that's something that's a little bit unique. Not shown here, but was also true is our junior level design course, which we call integration, is also interdisciplinary. So we are bringing these students back together as often as we can to really get them to work as teams and in those different modalities. All right. So that is our curriculum. And again, I'm happy to go in depth, but that kind of just shows the uniqueness of DU's curriculum. In a lot of our, otherwise it's going to look really similar to a lot of engineering curriculums. You're going to get those really technical skills, but you're also going to get cool modern tools like learning to use SolidWorks or learning different programming languages, depending on what your major is. One thing I love to point out is that you've probably heard University of Denver is a huge school for different international opportunities like study abroad. And one of the most popular questions I get is, can engineering majors study abroad? And the answer is yes. We are so fortunate that because DU has this really strong study abroad program, that we are able to make it so that our students are able to study abroad. It looks a little bit different for our engineering students only because they study abroad the fall of their senior year. A lot of campus goes abroad during their junior year. And this is just because our students are, taking their junior year to really be in those specialized courses to learn about engineering before they do that senior design project. However, in the fall of their senior year, our students are able to still work in senior design, be on a team. They just do the course remotely. We were doing this, pre-pandemic, but now that we have these tools like Zoom and, Teams meetings and all of these remote options, it's actually pretty simple for our students to be in 3 different countries and be able to be working together as a team. So I think not only do our students then still have the opportunity to be abroad, but even with that, they're gaining this really valuable experience of what is it like to work on a team where not everybody's in the team's same time zone, right? Let alone like in the same office building. And so it's really a cool experience for our students as seniors. Where students study abroad can vary. In the mechanical engineering department, we're pretty flexible. We can have students go to lots of different programs. Electrical and computer, there's several programs that they have that they can still take the required courses that they need. And so we really try to, work with the students, let them know what programs would work for them, and give them those options. I just talked to a student today who was in Sweden last quarter and stopped by to say hi and chat, and he had just a wonderful time. And it's so great to be able to see our students go and get these experiences and then come back and finish their senior year here on campus. All right. So international experiences, I think, is a really unique and great thing. We also have a very large percentage of our students who participate in undergraduate research. So DU, we have this really strong teaching foundation. We have this really great teacher to, faculty to student ratio. We have these small classes, but we're also an R1 institution, which means that we have these amazing researchers who are not only in the classroom, but are also in the laboratory doing incredible work. And so we have these great opportunities for our students to work with faculty. Not only do they get to listen to them teach, they then get to actually really see what they're doing in the lab. And so along with being able to, work with this faculty and see what they do, quite often students will work in the lab with them. DU has an amazing signature work program where they offer grants and funding for students who want to participate in things like undergraduate research. So if they have a project that they're working on, they can reach out to get funding for this so that that is something they can do instead of worrying about, having a different job that quarter or those kind of things. And so being able to do undergraduate research is something our students really enjoy. And quite often it might spark their interest in an area of research they hadn't considered, or even really, spark their interest to go to graduate school. And of course, we have master's and PhD programs as well. So they're working with those graduate students along with the faculty themselves. All right. I think I had one question pop up, so I'm just going to see if I can check that. Okay. Yes. So someone asked if the math classes our students would be taking are going to be similar to a physics major. Yeah, we'd actually almost take an identical sequence, except I don't know off the top of my head because I don't know for physics. I don't believe they are necessarily required to take some of the later math classes our students take. So we take a full year of calculus, and then we'll take what's called calculus of several variables, or you may have heard it as multivariable calculus and differential equations. I do not know if physics majors takes those too, but as far as like the first year of calculus, that's going to be something that both a student getting a BS in physics and a student in engineering for sure would see. Okay. So a little bit more, I talked about research as far as like the undergraduate opportunities, but just a little bit more about what type of research is happening in our departments. So in the fields of mechanical and materials engineering, we have a really strong research set of our faculty that are researching in the field of bioengineering. So this includes biomechanics, which you can see some pictures of here. So things like human movement, orthopedics, looking at how medical devices are interacting with humans, as well as cardiovascular biomechanics. We have a couple of faculty working in that field as well. So looking at fluid flow, how the fluid mechanics of our body are working with cardiovascular and vascular systems. And then we also have faculty working in robotics. And I'm actually going to talk a little bit more about that on the ECE side. So this is a great interdisciplinary field because we have faculty that are working in kind of the mechanical engineering side of robotics, but also the electrical and computer side. And additionally, we do have some faculty in material science, so working on things like computational modeling of materials, how they react to different forces, pressures, heat, stress, all of those kind of things. So as mentioned, in electrical and computer engineering, we also have a really strong robotics program. So faculty that are working on things like unmanned vehicles, as well as social robotics. So working with robots that are actually having interaction with humans. And so we have, coursework and things on things like human robot interaction, which is something that's really exciting and new. And there's also faculty in our computer science department working in some of these areas. So again, highlighting kind of the interdisciplinary nature of our school and how, you need skills from lots of different areas to be able to be successful in these. Okay, and as far as student support, I already talked a little bit about on the teaching side. We're really love to be engaged with our students. Teaching is my favorite thing. Believe it or not, I get to teach at 8 a.m. tomorrow, and I actually really enjoy that. I don't know if the students like being there at 8 a.m., but I'm always excited to be there. But we also have a lot of student groups too. So there's a lot of peer support. So groups like Society of Women Engineers, IEEE, which is the International Society of Electrical and Electronics Engineers. We have students who've started a lot of their own clubs, including like our theme park engineering group. So they are students that are interested in working on things related to theme parks like roller coasters, and they're having a miniature golf tournament in a few weeks so that they're going to build themselves. So lots of fun things going on, but lots of different clubs and groups. Again, being smaller, I think it's really fun to see our students pick things that interest them and run with it, and coordinate and collaborate with each other. So along with the student group support, there is, of course, lots of academic support. Not only do we have, our instructors and teaching assistants that are going to be in the courses, and I will point out all of our courses are taught by faculty, except maybe, TAs are in the lab, but even faculty are really behind those. We also have our Science and Engineering Center and Math Center that are located in the Academic Commons, which is free tutoring opportunities for students who, maybe you have some questions about your physics class or your calculus class. There's going to be free tutors there that you can go and find support for as well. So lots of opportunities for our students to get support both from each other, but also from campus and from their instructors. Okay. And then, of course, especially because I often have parents in these meetings as well. So what is the career perspective, right? So I think the good news is engineering degrees have great career placement in general, and DU is is not, an exception to that rule. So we have placement of, I think I'd have to look at our numbers exactly for this year, but somewhere around, 95% of our students are placed in a career in their field within 6 months. And these are some examples of companies in the past few years where our students have either had internships, co-ops, or career placements. We do have a small co-op program. But I'm happy to talk, a little bit more about that. But internship wise, the past, I'd have to look again at our numbers, but I know for at least the past few years, about 100% of our students in engineering have had either an internship or something like an undergraduate research experience. And we have a STEM specific career advisors that are really helpful to our students. So, there's a big difference between interviewing for an internship in accounting or communications or engineering. And so having career advisors that really know like what is going on in the engineering world, what companies are looking for, those kind of things is really beneficial. So we have a great relationship with all of those folks over at the Burwell Center who are going to be helping our students as they're going through their career path. And I usually don't have to sell Colorado. It is obviously an amazing place to be. So not only is DU this kind of beautiful collegiate campus that's right next to the city, but of course we also have the Kennedy Mountain campus and just the mountains in general nearby. I'm biased. I'm a Colorado native and I came back for a reason. And so I truly, know this is a great place to be. And it's a great place to visit. So if you're a parent and you're sending your kids to Colorado, wouldn't you love to come out and visit them? So great place for everyone to be. All right, I'm going to have this slide up is going to have information. So if you have questions afterwards, please feel free to, note my email. As well as I said, Dr. Martins is my counterpart in electrical and computer engineering. So feel free to put his email down if you have any questions. We also have a great group of student ambassadors that are really awesome at answering questions that are from a student point of view. So because some people ask me like, what dorm should I live in? And I say, I have no idea. And so we have students that can answer, much more student-oriented questions. And that is that last email address, that ecs.ambassadors@du.edu. But for now, I'd love to, answer any questions, open the floor to that. So if you have any questions, I'm going to stop sharing only because, well, actually, I'm going to leave it up for a second because I want you guys to get the email addresses. But otherwise, I may stop sharing in a second just because it's harder for me to see the Q&A. But please feel free to type all those questions in right now. Okay. Someone asked, you do anything with aerospace engineering? Yes, is my short answer. So I kind of showed that curriculum grid. One thing that is not like super clear in that grid is that we do have engineering electives that our students take during their junior and senior year that are in much more specialized fields, for example, aerospace engineering. So we have a couple courses where you could look and learn about that. That being said, we also have a lot of students who end up working in the aerospace industry. And so even though our degrees aren't in aerospace engineering, mechanical, electrical, and computer are amazing degrees that are really versatile in a lot of different fields, including aerospace. Colorado is home to a large amount of Lockheed Martin workers. And so we have a ton of folks who end up either doing internships or working for places like Lockheed Martin or Ball Aerospace or lots of other places. So certainly something that we do have experience with both our students kind of in the classroom and then also in internships and career placement. Yeah, someone asked about the difference between kind of explain the co-op program versus internship. So we do offer co-ops. What those are, the idea of a co-op is it is an opportunity for a student to actually take time off of school. Most of the time it's for a full year, but sometime it could just be perhaps for like half a year or a quarter where they'd go work for a company. You get paid, which is great. And then come back to school and then finish up your degree. So quite often, for example, a student would go maybe between their junior and senior year, spend a year working for a company, which is called a co-op, and then come back and finish their senior year. So their total time, might look like 5 years, but for a year of that, you're working, you're not paying tuition during that time, right? And then you're gaining really, really great experience that then when you graduate, you already have a year of engineering experience under your belt. We do have some students, we have a few students who do that every year. They really like them. Internships are usually something where you're taking that while still in school or over the summer is quite often what students are doing for internships. And so they may go work during an internship during the summer, but between, like their second and third year, and then, come back, do their third year of school, maybe do another internship the next summer. But those are usually not, they're happening while you're still a student. You're not actually taking time away from school for an internship. All right. Next question. Is there any overlap with business, finance, or data analytics and engineering, such as a dual degree or a minor? Those are options. Dual degrees are with engineering complicated. No, I don't want to say complicated, but it's a lot, right? Engineering has a lot of requirements. We're really great at getting students completed with all of those requirements. But when we start to do things like add a second degree, it becomes pretty complicated. But we can, right, have those conversations. You certainly would have the option to take courses in any of those fields as part of your common curriculum or as part of some of the electives that you might have. And then I do have a lot of students do minors, especially mechanical engineering. We're pretty flexible with that. So I'll have students do minors in business administration or in computer science. With the data analytics, we have a data science program at DU it's at the master's level, but there's some computer science classes that feed into that. And so that could be an option as well. All right, other questions, please feel free to keep typing those in. Okay, stop sharing just so it's easier to see all of the questions as well.
Okay, I think that's all the questions. Thank you, Dr. Rizal. I really appreciate your time this evening, and thanks for everyone who's able to join us. And we will be adding this to our YouTube playlist. You'll be able to find this recording on du.edu/visit. She shared quite a bit of information. And so if you ever need to be able to go back and fangirl like I do, then you can do that on our website. So thank you everyone for your evening and your time, and have a good rest of your day. Bye-bye.